Here is another way to ask us to find the derivative. We have a d dx in front of something. So that d dx in front of something says find the derivative with respect to x. In this case, the answer would be bring the 4 out in front, makes 28, subtract 1 from the exponent, and we're done. So these ones that are straightforward powers, it's really easy to use the power rule. Sometimes we get ones that aren't straightforward powers. Ooh, this one is about as hard as I can make a power rule. I've got the cube root of x squared on the bottom. So first of all, before we can find the derivative, we have to think, can we write this as a power? Well, a cube root is the same thing as a power of 1/3. So x squared with a cube root around it will be x to the 2/3. This still isn't a power because it's in our denominator, but then we can use our negative exponent rule and that x to the 2/3 in your denominator is the same as an x to the negative 2/3 in your numerator. And are you okay, like I just wrote, are you okay with this? That moving that x to the negative 2/3 into my into my numerator is the same thing as having 7/3 out in front times by x to the negative 2/3. Because technically, I could make that x to the negative 2/3 over 1, multiply the tops, multiply the bottoms with my fraction rules to make it equal to the same thing. But now that this is a power, oops, not inverse. Now I can find my derivative. That negative 2/3 comes out in front. Becomes negative 14 over 9. Subtract 1 from the exponent, and like I said, you are going to get really good at subtracting 1. Right? How do we subtract 1? Well, that'd be like subtracting 3 over 3. Get a common denominator. And we have our answer. Ooh, can you work backwards? If the derivative was 5x to the 4, what's a possibility to be the starting function? X to the 5th. Right? Working backwards, if we subtracted 1 from the exponent, working backwards, we'd have to add 1 to the exponent. And if there was a 5 out in front, can you see that that 5 would have moved back into the exponent? Now, this working backwards one was fairly straightforward. A little bit more complicated. We have a 12x squared. So I would probably think, well, if I added 1 back to the exponent, I would need an x cubed. What would have to have been in front? You're right, a 4, so that when that 3 comes out in front, it makes the 12. We're going to find out later that we can do derivatives of more than one thing at a time. And there could have been a number here. Because the derivative of 4x cubed is going to be 12x squared. And if there was a number here like, oh, Eric, what's your favorite number? 7. If there was a 7 here, what's the derivative of a constant? Derivative of a constant would be 0. So you could have had a 7 there and it would still be the same thing when working backwards. But for this one, all we needed was the 4x cubed. But later on, we'll realize that we could have more than one possible answer to this. And that's why this question said, find a function, because you just had to find one that works. You don't have to find them all. So, questions for practice out of your textbook, page 83 and 84.